Alright guys, let's go ahead and begin here with our next lesson on logs. We have a couple of these things left to finish up our chat about those. Alright, so what we're going to do today is we're going to learn something called the change of base formula to simplify expressions of logs where we can't get the base and argument to match. Now, we've done problems like this before, right? And the reason we could do those is because we could get the base and the argument to match. All I would have to do is rewrite that logarithm argument to look like this, and then since the base and the argument match, those cancel and my answer would be 2, right? So that's what we learned. However, there are some issues. What if I were to give you a problem like this, log base 2 of 12? You're not going to ever be able to, just in your mind, conjure up an answer to what you would have to raise 2 to in order to get 12. So we can't get the bases to match that way, and that's what we're going to learn how to deal with today. We're going to learn how to use a special formula called the change of base formula, which will help me simplify an expression like this where I can't get the base and the argument to match. Therefore, if I can't get the base and arguments to match, I can't use those properties that we've been using to get our answers. So let's go ahead and begin. I'm going to begin with a demonstration. Now, just so you guys know, I'm not going to be checking notes for the rest of the year. I mean, it's kind of just too much of a hassle, honestly. It's not worth it. And I'm just going to let you guys be big boys and girls. And I hopefully, if you're a good student, you understand the value of notes. And also remember, Mr. Bailey doesn't use a textbook, so your notes are your book. So if you don't have a written record of things that you've done, you have no written record. You have nothing to look at, nothing to use. So I'm going to leave it up to you guys to take notes on your own without me giving you points for it. It's just something that I'm going to encourage you to do, but I'm not going to make you. As for this slide here, I'm going to say I really wouldn't worry about writing this slide. I would just watch, but the slide after it and everything after that. So let's do a little demonstration. Let's look at the problem that I had up earlier. Now, to solve this problem, I'm actually going to use a property, and the property I'm going to use is a weird one. So before I start solving this, let me show you guys something here. A property that we learned a little while ago was this one. When you have an exponential expression where you have a number being raised to a power, and that power is a log with the same base as that base of the exponential function itself, basically these two things just cancel each other out and we're left with just x, right? That was one of our properties that we learned about. I'm going to be using that property to demonstrate something to you guys. So I want to know, what the heck does this thing equal? That's my goal. I can't get the bases to match. So what can I do? I can't get the 12 and 2 to match. Well, here's what I'm going to do. There's my base. My base is 2, right? So I want a base of 2. So here's what I'm going to do is I'm going to make this whole thing here a power of 2 now. So that whole side becomes a power of 2. And I'm allowed to do that so long as I do the same thing on this side. So that whole thing now is also going to become a power of 2. So instead of log base 2 of 12 equals question mark, I've got 2 to the power of log base 2 of 12 is equal to 2 to the power of question mark. So let's see, what can we do now? Well, we can use this property. As you guys can see, this thing here looks an awful lot like what we got going on over here. And this are just going to cancel, and I'm left with 12. So I've got 2, do that, 2 to what power equals 12? Well, now here's where things are going to get kind of interesting. I'm going to log both sides, but I'm going to take the log on both sides. Let me just write that out and I'll show you what I mean. So I'm going to take the log of 12, and I'm also going to take the log of 2, but I want you guys to notice something about my choice here. I chose to log both sides, but I logged it with log of what base? There's no number there. The base is 10, right? I chose to use base 10. Now, why did I do that? Well, probably not immediately obvious yet, so just bear with me here. But first thing I did was I made both of these a power of that number, cross that off, leaving me with this, and then I logged both sides with a base of 10, and you might be wondering why the heck I did that, and we'll get to that in a minute. But for now, that's where we're at. Now, here's one thing that I can do since I logged both sides. We have a property that we learned a little while ago that said this. If you have log base a of b to the x power, you can rewrite that as x times log base a of b. In other words, you could take that power and just throw it up to the front. That was one of our properties that we learned before we went on our break. Do you guys see anywhere where there's a power in this expression? There it is. I can take that and I can move it over here to the front. Okay, so if I do that, I'm going to have log 12 is equal to question mark times log 2. Okay, whoopity-doo, right? No big deal. What's the big deal of that? The next thing I'm going to do is I want to get this. Remember, I'm trying to figure out what this equals, aren't I? I want to know what is that, what is my answer, right? So I want to solve for the question mark. How do I get the question mark by itself? Well, if question mark times log 2 equals log 12, I can just divide both sides by log 2. Having some technology issues. Divide both sides by log 2. And now there's my question mark. And you might be thinking, well, what the heck was the point of all that? I mean, we started earlier up here with this nasty looking expression, right? Let me clean it up a little bit. Clean all this up. Get all this ugliness out of the way real quick. I'm about ready to make a good point to you guys about why we just did all that. Okay, so we started off with this expression here, right? And now we ended up with this. What's so great about this expression? Why do I like this better than this up here? Well, here's why. What's the base of these logs? The base of these logs are both 10. And what's special about that is the fact that I can use my calculator now to get my answer. So check this out real quick. Get out of this screen for a second. Bring up my calculator. All right. I'm going to go ahead and we had as an expression there, we had log 12 over log 2 is what we ended up with as our final answer there, right? We can type that in a calculator since it's base 10 because our calculators have two logs on them. It has log, which is base 10, and it has ln, which is base e. So since we have log base 10 over here, we're going to do that. We're going to do 12 log, so that's the log of 12, divided by 2 log. So you, depending on what calculator you use, how you punch this into your calculator makes a little bit of difference. And then I push equals and I get 3.6. 3.6. So what's the point of all this? Let me back up and I'll show you one more thing and then we'll be good to go. What I did was I rewrote this expression so that it looks like this. And the benefit of this is that it has base 10, which means I can use my calculator. And I punched that into my calculator, and I found out that the answer to this was 3.6, which means that this answer up here is 3.6. This is what we call the change of base formula down here. What I did is I had a log that had a base of 2. And I rewrote this expression using a few properties to look like this now, where the 12 goes on the top, the 2 goes on the bottom, and both of those have a log of base 10 next to them. And that will tell me what the answer to this is. I couldn't do this before on my calculator because it has a base of 2 and my calculator doesn't have a base of 2. But I changed it into an expression that has a log of base 10 so I can use my calculator to get the answer. Okay, so that's what we call the change of base formula. And instead of having to figure it out every time, we can just have a nice little formula now. Here it is. This is where you guys would want to start writing. So if you have a log with a base of A and an argument of B, and you can't use any of our properties or anything like that to figure out the answer, you can rewrite it with a base of 10. The B goes on the top, the A goes on the bottom, and both of them are going to have a log of 10. And then from there, we just use a calculator to get the answer. But this is really the change of base formula here. So log of base A of B can be rewritten as log base 10 of B divided by log base 10 of A, which we can get an answer for by using a calculator. And that's the change of base formula. Okay, so let's go ahead and put this to work for us a little bit. But I think we've already answered this question, but it's a nice thing to have in your notes. Why do we even need the change of base formula? Because there are some problems that we can't do by hand. Like, for instance, log base 2 of 12. We don't have any properties or anything that we could do, just going to help us get that by hand. And since our calculators only work with base 10, we can just rewrite it like this with base 10 logs instead, and then we have our answer. Okay, so that's the change of base formula, and that's how it works. So let's go ahead and put it to work for us here. Now, the directions give us 2 steps. It says evaluate each expression, but then they also want us to use the definition of a log to make sure that our answer is a good answer. And I'll show you what that means as we do. So let's go ahead. Let's go ahead and take a look at our first example here. Suppose I wanted you guys to find log base 3 of log base 3 of 10. Well, I'm not going to be able to get 3 and 10 to match. I can't rewrite 10 as 3 to the power of something. So we're going to have to use the change of base formula. So what we do is we do log. On the top, we put the argument, and on the bottom, we put the base. The base goes in the basement. It's a good way to remember it. So now what we're going to do is we're going to punch it into our calculator. And we're going to get an answer. Now, for those of you guys that are not remembering how to put it into your calculator, I'll walk you guys through that really quick. I'll bring that back in just a second. But bring up my calculator. Depending on what kind of a calculator you're using, if you're using one like this one's a little bit like the cell phones. You have to push the number first and then the log. So I want to enter this expression. I want to do log 10 over log 3. Right? So here's how you do that. You enter 10 first, so go ahead and type 10 and then press log. Now notice the answer is 1. I'll explain that in a minute. But Now to get the fraction bar, we're going to push divided by, and then we do the bottom part, 3 and then log. So press 3 and log. And then finally you have to push equals. This answer here is just what log 3 is, so if we want to find out what the actual division is, we have to push equals, and it's 2 point, if we just, let's round to the third number here, the thousandth place, 2.096. 2.096. All right. Back up a little bit here, bring back all of our stuff we had. So I'm getting 2.096. All right. So that's step 1. We evaluated the expression. Log base 3 of 10, we rewrote it as log 10 divided by log 3, and the calculator tells us the answer is 2.096. But what does this mean? Use the definition of a log to verify your answer. What that means is we're going to take here's our answer, log base 3 of 10 equals 2.096, right? What we're going to do is we're going to rewrite it in exponential form, okay? This will be a little bit of a review for you guys. So here's my base, it's 3. This is going to be my power, 2.096. And once again, we're going to check to see if this actually makes sense on our calculator. So is it true that 3 to the 2.096 power is 10? Well, let's just think for a second. What's 3 to the second power? 3 to the second power is 3 times 3, which is 9, and that's pretty close to 10. So just a little bit more might bump it up to 10. Let's see if that's a reasonable answer. Go back to my calculator here. How do we do that on the calculator? So if you want to type in 3 to the power of 2.096, we're going to start by pressing 3. You got to find your power button. Different calculators work a little bit differently, but in this case, mine is the X to the Y button. There's that. A lot of calculators look like this little arrow here that you guys see for the power button. So that's 3 to the power of 2.096, and then you just push equals, and it's really close to 10. Why is it not exactly 10? Because we had to round our answer. So that's what they meant on the slide by use the definition of a log to check your answer. So back up a little bit here and review real quick before we do another example. So we started off with this problem. We couldn't do it by hand, so we used the change of base and a calculator to get this answer. Now we want to make sure that this actually makes sense. Is it true that log base 3 of 10 is 2.096? The way we're going to make sure that that makes sense is we're going to change it to exponential form. 3 to the 2.096 power equals 10. We're going to check that on a calculator as well, and it should come out to be pretty close to 10, and it does. So that's a overall review of it. Let's do another example here. Log base 9 of 6. Now you're not going to be able to get these bases to match. Okay, so we have to use the change of base. So the first thing I'll do, we'll kind of treat this like a guided practice. Why don't you pause the video here and see if you guys can write the next step. What you guys should have gotten here is you should have gotten log 6 over log 9. This number goes on top, the base goes in the basement. Then we're going to use our calculator to get the answer. So if you want to pause the video here and give that a try, go ahead. I'm going to work it out myself. So that's what I get. So we have log base 9 of 6, that was the original question, is equal to 0.815. Now we want to use the definition of a log to verify our answer. In other words, we want to change it into exponential form and check our answer on a calculator. So Go ahead and change that into exponential form. Go ahead and pause the video here once again and write it in exponential form. This is what we should have written. 9 to the power of 0.815 equals 6. And this is what you would check on your calculator. You would punch in 9 to the power of 0.815. You should get 6. If you don't, then our answer is wrong. But that is our final answer because we checked our work and it worked out. All right. So I'm going to throw a student practice at you guys now. Student practice. Log base 4 of 20. Go ahead and see if you guys can get the answer. Pause the video here. Okay. So log base 4 of 20 using the change of base is log 20 over log 4, which is 2.161. So the answer to log base 4 of 20 is 2.161. Changing that into exponential form, we would get 4 to the 2.161 power equals 20. Checking that on our calculator verifies that it's a good answer. So 2.161 is in fact our answer. All right. Let's go ahead and move on to a second type of problem. In these types of problems, what you're going to be given is you're going to be given a function, a log function, I should say. And you're going to be asked to find what, for instance, f of 5 would be. What is f of 5? Okay. Well, first of all, when you're looking for f of 5, what that means is plug 5 in for x. So f of 5 is going to be log 4 of 2 times 5 minus 3. Now, what is 2 times 5 minus 3? That's 10 take away 3, which is 7. So f of 5 is log base 4, 7. Well, we can't get these bases to match, so guess what we do? We do our change of base. And from there on out, we just use our calculator. $1.404. And that's where we're going to stop. On these problems, we're not going to verify our answer by using the definitional log. In other words, we're not going to rewrite it as an exponential function and check it out to make sure it's good. We're just going to finish it off. That's it. So all I want to draw your guys' attention to is it's really the same question, it's just written differently. I'm giving you a log function and asking you to plug a number in and get an answer out. To do that, after you plug your answer in, you do your math in there and work it out using the base, and you're good to go. I'll give you guys one of these as a student practice real quick, just in case that's kind of weird to you. You want to try it out. So let's try it. Let's say I gave you guys f of x equals log base 2 of 2x minus 1, and I want you guys to find f of 10. Go ahead and pause the video there and give it a try. So there you guys go. F of 10, to find that, you would plug 10 in for x, which would give you this. 2 times 10, take away 1 is 19. We will not be able to get these bases to match, so we can't use our old properties to solve it, so we do the change of base instead. And then our calculator gives us 4.248. All right, I'll do one more example for you guys before we call the end of this lesson. We'll call this example 3 then. It's really just kind of similar to example 2. Maybe a little bit harder. let's say that we have f of x is equal to 2 log of 7x plus 5 minus 8. And I wanted you guys to find f of 1. Okay, well, same thing we did last time. We're going to start by plugging in the 1. Next thing we're going to do is simplify this. 7 times 1 plus 5, just like last time. Nothing new yet. That would be 12. I forgot my base, didn't I? I need to put a base on it. Let's call it base 2. Sorry about that. I guess I could have left it off. That'd be base 10, but there'd be no point in giving a problem like that because no need for a change of base when you have base 10. You just do it on your calculator as it is. But anyway, I digress. So after we do this, we get 12. And now we are going to take care of this using the change of base. So we're going to have log, oops, I don't know if I wrote that. I'm going to rewrite that as log 12 divided by log 2. So I rewrote that boxed expression into this parenthesis expression here using the change of base. So now using my calculator, I'm going to figure out what that is. Log 12 divided by log 2, 3.585. And from there, guys, we're just going to do it on our calculator. We're going to do 2 times 3.585, and then we're going to subtract the 8. Got to follow your order of operations, basically. And so what I end up with here as my final answer is negative 0.83. Okay, last student practice. Let's say that I had f of x is equal to 2, well, I don't want to do 2, negative 3 log base 9 of 4x plus 10 plus 5. And I asked you guys to find f of 2. Go ahead and work it out, pause the video, and there you guys have it. So f of 2, we plug 2 in first. 4 times 2 plus 10 is 18. Log base 9 of 18 has to be figured using the change of base formula, which on our calculator we can find to be 1.315. Multiply that by the negative 3 and add 5 to get your final answer of 1.054. That's the end of our lesson, guys. Your homework is attached as well. Go ahead and knock out that homework and submit that picture to me via Google Classroom.